Hello students of class 5, how are you? I hope all of you are enjoying your days. Now in today's class we'll discuss about the matter. Now first of all we'll see what is matter. Now we know that anything which has weight and takes up space is called a matter. Now here matter can be living things or it may be non-living things. Living things like animals, birds, plants, whatever in and around you, all are matters because all of these they have definite weight and they takes up certain space. Similarly, among the non-living things, we have plenty examples like the pencil, whatever, or pen, whatever you are using, your books, copies, and anything that takes space or have weight, we call them this is matter. Now, the amount of space a matter takes up is called its volume. Now, matter is made up of tiny particles. Okay. These are so small that we cannot see, sometimes we cannot see them with our naked eyes. With the help of microscope, we can observe them. They are much smaller than a grain of sand. Now, in a matter, millions and millions of these tiny particles together, it takes up a shape. So millions of these tiny particles together form a matter. And these tiny particles are called molecules. Okay? Now the molecules of different substances are different from each other. Like molecules of your cup or plate and the molecules of your glass, molecules of your chair, all are different from each other. Now, on the basis of their differences, matters exist as solid, liquid or gases. Now first of all, let us see what are solids. Table, chair, books, your cup, plate, pencil, pen, all these are solid. If we take a solid or any such matter and place them in some other places, their shape and the space they occupy, it does not change. It will remain the same. The shape of your pen, it will remain same wherever you keep it. Or your book, the shape won't change. So we can say that solids have a definite shape and volume. Now, why solids are so strong? Because generally in solid, the molecules are packed close to each other. All the molecules are tightly packed. As a result, solid can take a definite shape of its own. It doesn't change or it cannot change its shape. In liquids, the molecules are loosely packed. Like in case of water, milk, or say whatever juices, oil, all these things, these are liquid. And since here molecules are loosely packed, we cannot carry it like a solid substance. We need a container for that. Either you will need a bowl or you will need a bottle. We can pour a liquid in a container from another container. Now, here what happens, in solid it has definite shape. The shape doesn't change wherever you keep. But in case of liquid, what happens, if you take liquid in a bottle, it will take the shape of the bottle. Again, same liquid, when you pour in a glass, it will take the shape of a glass. If you pour it in a bowl, it will take the shape of the bowl. But here, the volume of the liquid, it does not change. If you take 1 liter of liquid, 1 liter of well, wherever you keep, if you keep it in bottle, it will remain 1 liter only. If you keep it in a bowl, shape will change, but it will remain 1 liter only. The volume won't change here. Now, a liquid has a definite volume, but no definite shape. In a liquid, the molecules are not packed as close together as they are in a solid. Okay. Now, in case of liquid, they can move around more freely, and this is why liquid can flow. It cannot remain in a place. It flows down. In case of gases, the molecules are far away from each other, so they can move around freely in a space available to them. For example, air is a gas. Okay. Now, a gas does not have a definite shape. Molecules of a gas can be squeezed into a small container or spread out in a big container, just because their molecules are very loosely packed. For example, when you blow air into a balloon, the air is squeezed into the balloon, and when you let it out, it spreads all over the room. It now occupies larger volume. So we can say that a gas does not have a definite volume. Now, we'll see how change of state occurs. We know ice is a solid. It has definite shape. It has definite volume. It can occupy a certain space. So we can say ice is a solid. If we heat ice, it will become liquid. The ice will convert into water. So water is a liquid. So we can, that times the ice will take in the liquid form, the ice will take the shape of a container where we will keep. Again, if we go on heating this water, this liquid, it will change into a gas. What we call this one? We call this is a water vapor. Thus, we can say that a solid becomes liquid on heating. A liquid becomes a gas on further heating. Again, in reverse way, if we cool or on cooling, the opposite changes takes place. Like if water vapor is cooled down, it changes into water. This water again, if it's cooled down or if it is cool, it changes into ice. Thus we can say that matter can change from one state to another on heating or cooling. One more example of this one is butter. It is a solid. If we heat this one, it will convert into liquid. On further heating, it will convert again into gases. The butter and wax, it melts down when we heat them. Similarly, iron, it also melts on heating. Okay, around 1000 degrees centigrade, iron melts into liquid. So it requires much more heat than butter or wax or ice. Melting of iron is done in a factory. A special kind of device is there, which is known as furnace. It is an equipment, okay, in which things can be heated. This cannot be done at home or in school because it requires high amount of heat. Next we will see water solutions. Now, if you take a glass of water, and to it if you add a teaspoon of sugar, go on stirring this one, ultimately you will find that all the sugar will get disappear. This sugar will mix in water. It will get dissolved in water. The water with that dissolved sugar will taste sweet. So this sweet water we can call a solution. Solution of sugar in water. Similarly, if you pour a teaspoon of salt and stir it, teaspoon of salt in a glass of water and stir it, after some time you will find that all the salt gets dissolved in water. That times the water will taste salty. So this sweet water or salty water, it is called solution, okay, and the sugar or salt that get dissolved in water, it is known as solute. So the water that dissolves the solute is called solvent. So we got three terms: solution, solute and the solvent. The solvent may be anything, okay, any liquid, but water is a universal solvent. Now, all solids, we cannot dissolve all solid in water. Okay, so you can say all solids do not dissolve in water. Solids that dissolve completely in water are called soluble substances. Can you dissolve sand in water? You take a teaspoon of sand in a glass of water, go on stirring. If you stir it for whole day, then also you'll find that it remains as it is in the bottom of the glass, because sand doesn't get dissolved in water. The substance that dissolve completely in water are called soluble substances. Example, sugar and salt. And the solid that do not dissolve in water are called insoluble substances. So here sand is an insoluble substance. Now we know that in a liquid the molecules are not packed very close together. There are some spaces between the molecules. When sugar dissolves in water, the sugar molecules fill these empty spaces. There are plenty of spaces are there. So these sugar molecules, they can easily make its own space in between the molecules of water. That is why there is no increase in the volume of water. Now, you can note one thing. In a glass of water, take 1 teaspoon of sugar, stir it, it will get dissolved. Add another teaspoon, stir it, it also will get dissolved. So similarly, if you go on adding sugar to a glass of water, same glass of water, again and again, after some time, you'll find that the sugar stops dissolving. Even after you stir for longer period, the sugar won't get dissolved. That doesn't mean that sugar is insoluble. Here what happens, the sugar molecules already filled up the empty spaces in between the water molecules. So there is no more spaces. There are no more spaces for the remaining sugar molecule to adjust over there. So as a result, the sugar molecules remains insoluble. Now, why does the sugar stops dissolving? This is because all the empty spaces between the water molecules are now filled with sugar molecules. So no more sugar can dissolve in water. Such solution is called a saturated solution. Same thing you can experience with salt also. After addition of some salts, you'll find that you cannot add it. The salt molecules, the salt you can see at the bottom of the glass, because that solution is already, that sugar solution already filled up all the spaces between the water molecules. So that such type of solution is called saturated solution. So in this chapter we have learned many new things. First of all, what is matter? then what is volume, then what are the different states of matter. Different states are solid, liquid and gases. After that we learned water solution, water solute and water solvent. Then water soluble substances, water insoluble substances. And lastly we have learned what is a saturated solution. So that's all about matter chapter. In next class we'll discuss about our next chapter, that is our clocks. Thank you.